Good afternoon, everybody. How's it going? Jack, congratulations and celebrations. Jack got in first. Well done, Jack. What a ledge. Oh, Winkit's here. How's it going, Winkit? Oh, God.
Jack got in first. Well done, Jack.
Oh, no, I need to turn that off. There we go. Right, guys. Last lesson of acid base today. Whoop, whoop. Oh, Jack, just ignore them. It's fine. Right, I'm going to switch my tablet into tablet mode. Right, last lesson of acid base today, guys. Solubility. So I'm just going to share my screen. Let's crack on straight away. I'll then change my camera settings so that you guys can see my forehead. Winner! I still need to lower my camera. It's on my mind. It's on my mind. Look at that. NASA. Right. Let's crack on today, folks. So you literally do just stare at my head the entire time, except when I look up. I need to try and work on that. Okay. Shared screen. Everything's running. Oh, Winkit, very bored at home. Winkit, I need your help with some Steam projects. Definitely. I'll send you a message on Hangouts later today. Right, guys, 4 learning objectives today. So learning objective number 1, know solubility and temperature. Yeah, so this is solubility and how it changes. So I'm just going to change my chair. Raise myself on a bit. It's better, isn't it? Yeah, there we go. So how solubility changes with temperature. And the last time you saw this, guys, was probably in year 7 when you were talking about the dissolving of salt and sugar in water and the effect of temperature on that solubility. So we'll talk about that in a bit. I'm also might be adding something new on that one today for you guys. But as I said, if you have visited this before, it'd be nice to look at some solubility curves. Learning objective number 2, use solubility curves. These look like these. You need to be able to use these. They commonly come up in exam questions, so it'd be useful to be able to use those. Hi, Mita. Nice to see you. Thanks for coming. Next one is know your solubility rules. So, by the way, solubility rules. See what I did there? See what I did? Like rules, like it rules. Yeah, that's dad joke. So yeah, know your solubility rules. And last thing, understand the practical to find solubility. Mita, I'm good, thanks. How are you? Are you okay? It's lovely to have you on my channel. Mita is one of my favorite subscribers. In fact, I think Mita is actually my number 1 subscriber. I think so. Mita, you're my number 1 subscriber. Thanks. Okay. So the first thing we need to do, guys, is, unfortunately, definition. So in your notes, please, guys, you can just go definition. Definition, solubility. So solubility has is quite an unusual definition. And it's one of the ones which is a regular definition of GCSE because it's slightly higher level, and it's actually a 3-mark question, and it allows for a really good separation of students who've learned it. So solubility, the mass of solute that can dissolve in 100 grams of water at 25 degrees Celsius. That's the definition. So this is how, because the problem is, you see, when students learn this, teachers have a really bad habit. I'm included. Yeah, I am as faulty as the next chemistry teacher. Yeah, it's really easy just to say how much stuff dissolves. But unfortunately, that just doesn't cut it. Let me show you where the marks come from. The mass of solute that can dissolve in 100 grams of water at 25 degrees Celsius. The reason for these very particular numbers in the definition is because we know that if you have more water, you can dissolve more. Yeah, it doesn't mean you dissolve faster, but you could dissolve more. And now we also realize that temperature impacts solubility. So we also need to state a temperature. And STP, standard temperature and pressure. Standard temperature is 25 degrees Celsius in chemistry. Or for Winkit and meter, it's 298 degrees Kelvin. So now that we've defined solubility, we now need to add in this extra bit from key stage 3 of solubility versus temperature. So bullet point number 1. If you increase temperature, increase temp, the solubility of a solid, notice my capitalization, of a solid solute will increase. So increase. I always love it when they do that in chemistry. It's like increase temperature, increase rate. Yeah, and I love those. It's just really nice when an increase leads to an increase. Yeah. However, this may be new to you folks. Yeah. If this is a new one, this is new to you at GCSE, it should be really interesting. Meter Winkit, tell me whether or not you know this fact. If you increase temperature, if you increase temp, the solubility of gases, decreases. So I'll put this into some context for you. So one of the things that we all know is that fish live in water. Well, we know that what the fish are doing is fish are actually breathing underwater. They have gills, and those gills extract the dissolved oxygen, from the water. They're not breathing water, they're breathing oxygen like me and you. But they need gills to be able to extract the dissolved oxygen. Yeah? So here's the thing. When you buy a fish, what you're actually told to do, I've actually got a story about this. It's a really embarrassing story. So when I was about 7, I went to one of my school fairs with my dad. And when we were at the school fair, I won a fish. That's right. I won something. I won a fish. And they gave me the fish in a little bag with some water in it. I should do this as a storyboard. This will be amazing. Little Mr. Duncan. There's little Mr. Duncan with his glasses on. There we go. There's me. Yeah. And I went to the fair, and what I won is I won a bag, and it had a fish in it. Yeah, it had a fish. I won a fish. Now, when I then got home, what I then needed to do is I needed to put it into the fish tank. Yeah. I then needed to put it into the fish tank, and the problem was my dad told me, how to take care of a fish. That is correct. It's one of the learning objectives. You've told us this story 100 times. It's gone. Zina ruined it for me. And I was going to draw a lovely storyboard and everything. It was going to be awful. It's going to be so beautiful. Whatever. Fine. Story's dead. I killed my fish. All right. I killed 2 fish. It's fine. So anyway, if you boil the water, the oxygen leaves. And the fish die. Yeah. I'm not telling the story anymore now. No, I'm not telling the story. I'm like, my fish. You boil the water, by the way, to remove the chlorine. No, it's done now, Zina. You've ruined it. Whatever. Anyway, so let's go to our solubility curves. So what we can see here is in our solubility curves, all of these are going up. What this tells us is these are solid solutes. There is one, by the way, just one that breaks that rule, a cerium sulfate. Isn't that fascinating? No, I wanted the story. I don't know who Kilobyte is. Kilobyte, I've seen you before. Thanks for coming along. I wanted the story. It's a silly story. And apparently my kids don't like me very much, or at least. We'd love to hear it for the 101th. Zina, you are digging yourself such a horrendously deep hole. Rest in peace, fish. Yes, wink it, absolutely. But what I want to point out, cerium sulfate, that is a very special example. Let's quickly jump on and go solubility curves. I just want to show you a graph that has gases on it. Yeah, there are the gases. There they are. There they are. There they are. Boom. So there we go. So we've got this graph. See if I can zoom in on this. I've got my little fan set up. I'm melting at the minute. Sweetheart, can you put the aircon on? Thank you. Let's see if I can find. There we are. So the solubility curve here. So what we realize, guys, that we can identify at this point. I'm actually going to snip this. Snip you. Yoink. Oh, I've cut the top off. Whatever. I'll take you and go edit, copy. Let's lob you in here. Hello. Paste. There we go. So on this particular one, what you get to see is there are two lines that are decreasing. Just two. Let's identify them. Here are the two lines, and these are both gases. So we have ammonia as a gas, yeah, and we have SO2, acid rain causing SO2 as a gas as well, and that one's decreasing also. So as you increase the temperature, you drive out gases. Gases, that would be, by the way, what's happening is, if you want the equation for this, and I'm going to draw the equation for this, this would have been SO2 aqueous, and we then go, we heat it, and you get SO2 gas. So all that's happening is a state change. We're driving the gases out at the higher temperature, whereas it's the exact opposite for our salts. If you increase the temperature, the salts increase in their solubility. By the way, Winkit, you being one of my very, very best A2 students, Winkit, I'm going to set you a challenge. Why does cerium sulfate break the rule? And it's all energetics, baby. It's energetics. Yeah, look it up. Super interesting. Really cool, actually. And you can do all the calculations on it and everything. It's boss. I'm such a nerd. Oh, listen to me. Such a nerd. Anyway, so we know that solubility now increases. So what we now need to do is we need to look at our solubility graph. So let's draw a graph. Can you put a title, please, guys, of solubility graph? Solubility graphs. And let's just draw a couple. In fact, let's just draw one. So what we've got here is we've got temperature, temp, and this is high. No, shouldn't do that. Shouldn't do that. What I should do is 20 degrees, I don't know, 30 degrees, 40, 50, 60, 70, 80, 90. That looks brilliant. I'll stick with that. I'll take that one. Winner. There we go. Degrees Celsius, by the way. Got to always label your axis with your units. Don't forget. A couple of my GCSE kids threw that away. And this is solubility. Solubility per 100 grams of water. Yeah? So what we can do is we can then draw a line. By the way, it's nice to actually draw some real lines. So I like the potassium I need one that matches my scale. Perfect. Oh, potassium dichromate's beautiful. Potassium chlorate's pretty good as well. I like that. Like that. Let's go for potassium chlorate. So potassium chlorate's like this. It's perfect. KClO. Is it O3 or just O? KClO3. Wow. Potassium chlorate 5. So it is. Oxidation state of the chlorine is a +5 if you're interested. So anyway, so the potassium chloride is increasing. Now, what you can now do is the questions that are going to come from these. What are the exam style questions? Yeah, so underneath it, I'm going to go exam questions. Super common. Yeah, what is the solubility? What is the solubility? Whoop, that's definitely not what I mean. Solubility of KClO3 at 50 degrees Celsius. Show you're working on the graph. So what you do is you draw your dotted line, and then you draw your dotted line, and then you read off the value there as X. Yeah, and the answer is X. And you've shown you're working on the graph. You get both marks. Dead easy. Yeah. Next question. Next question might be, what is the change? What is the change in solubility? Change in sol between 30 degrees Celsius and 50 degrees Celsius. Show you're working on the graph. And what you do is you find 30 and you draw your lines off. You find did I say 50 or 60? 50, darn it. I'm going to go for 60 just because I've not drawn a line there yet. Yeah, let's go for 60. And I'm going to go, oh, right, now I draw up from 60 with my ruler, and then I draw across with my ruler, and then that is the answer. Yeah, and this is why. Because it's the change. Be careful. It's all about the tricks in the question, guys, with these graphs. Nice and easy. Yeah, and that's going to be why. We're done. So nice, easy questions, guys, using these graphs. There is a trap, however. There is a big trap. So I'm going to do one more exam-style question. What is the solubility of KClO3 at 50 degrees, at 70 degrees Celsius in 50 grams of water? Now, guys, it's a trap. It's a trap, Admiral Akbar. This is a trap because what's going to happen is you're going to read off the 70, read off the solubility, and the graph is per 100. Well, they didn't ask you that, did they? I'm going to call this Q. Yeah? So the answer for this is Q over 2 because I've got only half the water. Do you see the genius? Genius. Love it. Love it. Cool. So I think we've covered solubility graphs. They're dead easy. It just requires a little bit of, I want to say clarity. It's not the right word. You just need to have a little bit of patience on this, guys, and not rush these questions. Yeah? Okay, so let's look at our learning objectives. Solubility with temperature using solubility curves. Now we get onto solubility rules. Right, so what are the rules? So I never do this. I'm actually going to write it out with you guys. These are the rules. I kind of like these. I kind of like this table. It's actually a really good table. It pretty much covers everything. But in reality, I can actually make this a bit easier for you. Acetates aren't covered at GCSE. It's only at A level that acetates appear. So you can just, it becomes nugs, instead of nagsag, it becomes nugsag. Yeah, which you can read anything into you like in terms of how it sounds. Because nug sounds like something else. Nugsack, sag, and I'm going to move on now. Move on. So we've got solubility rules. Let's write them down. I'm going to write them with you. I never ask you to write anything. What if the last question was 20 instead of 50? Great question, Kilo. I like it. You probably don't like the word kilo, do you? I'm just going to call it kilobite. Call you bite. Your bite. Yeah. Good question. So if they had done, it is a really good question. Let's say they put 20 grams on instead. What you would do, too much hinting. What you may realize is that the 20 grams kilo is 1/5. It's 1/5 of the 100 I used. So if I do 100 divided by 20, I get 5. And what you realize is this is going to be Q over 5 instead, because it's 1/5. Does that make sense? Yeah, give me I can explain it to you in a slightly different way if you prefer. You know, if you have the image, it's super easy. Let's say we had 100 centimeters cubed of water here. By the way, nice to tell you, Kilo, that 100 centimeters is equal to 100 grams. Gangs, as there no second A. Jack, just don't worry about it. Let's say in this 100 centimeters cubed, we were able to dissolve into the water. Let's say we were able to dissolve 10 grams of solute. Yeah, until it reaches saturation. Well, if I had the same beaker and I only put 20 centimeters cubed in here, or 20 grams of water, it's the same thing, translates 1 centimeter is equal to 1 gram. Yeah, I would only be able, I'm only going to be able to do 1/5 of that, which is going to be 2 grams of solute. Yeah, I should have even counted the dots for that. There's 10. And then so we're only now going to get 2 because we've just got 1/5 of the volume of water. I hope that helps, Kilo. Great question. Thank you so much for asking. If you had 33 centimeters cubed, it would be 1/3. Yeah. If you had 150, you'd multiply it by 1.5. I hope those are useful. Right. So, solubility rules. Solubility. Later on in the show. Solubility rules. Boom. I like it. Right. So, solubility rules are how you know if something is going to dissolve. Yeah. So, the first rule here is just to mention nugsug. Nugsag. Oh. Yeah, it'll make sense in a minute, I promise. Nitrates. Nitrates. Group 1. Sulfates. Ammonium. And group 7. So these are the salts. Yeah, these are the salts that we're dissolving in the water. Now the first 2, yeah, understood. Thank you very much. By the way, call me KB. Oh yeah, no problem, KB, no problem. So the first 2 are super easy and there are no exceptions. Yeah. So the reason why this is divided into 2 particular sections, yeah, is because each section has its own idiosyncrasies. And the best thing about the top 2 is they're always soluble. Yeah, these are always soluble. There are no exceptions to that rule. So, for example, let's go e.g. Yeah, if I have sodium sulfate, let's go formulae, it's quicker. Sodium sulfate. I'm going to go aqueous. Yeah. Now people go, oh, but it's a sulfate. And I'm like, no, but it doesn't matter because it's group 1. As soon as you see the sodium, it's soluble, baby. So we're like, winner. Yeah, so soluble. We can go potassium nitrate. Wow, that is soluble, 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 and more soluble because it's growth of group 1 and group 1 and a nitrate. They're all soluble. This is like super duper soluble. Yeah, well done, Winkit. It is indeed in your salt bridges. Absolutely. Unit 5, chemical cells. Well done. Nice connection there. The question is, Winkit, what's the use of anhydrous sodium sulfate? You think about that. I'm gonna give you the answer now. Calcium, no, group 2, can't do it. Lithium carbonate. Soluble. Yeah, soluble, 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 soluble. Any group 1 salt, you're soluble, nice and easy. Yeah, any nitrate, silver nitrate, potassium nitrate, calcium nitrate, strontium nitrate, iron nitrate, they are all soluble. If it ends in a nitrate, it is soluble. Silver nitrate, got to know that one, guys. Really important for A-level and GCSE. Soluble, aqueous. Let's go for iron 3 nitrate. Soluble. Yeah, because it's a nitrate. They're all soluble. Winner. How good's that? Just soluble, soluble, soluble. Winner. So, now these guys, the sulfates, these are soluble, but there are exceptions. Yeah, these are all soluble, except, you shouldn't really write all. Soluble, yeah, there are exceptions. Now these exceptions now link to my next part of the solubility rules. Yeah, and what I'm going to do is we're going to tackle each one as we go. So the next one, underline it, is PMS. See what PMS? Yeah, stands for lead. Everyone's going, what? Well, if you want to do LMS, it's nowhere near as funny. The symbol for lead is PB. So I went for PMS. Yeah. Lead, mercury, whoops. My brain's ahead of my hand. Mercury and silver. That was the S I was writing just then. Yeah, let's put some ions underneath this. Pb 2+, Hg 2+, and silver Ag+. Know that guy. Yeah, nota bene, know him. Whoa, stupid tablet. know this guy. Yeah. So silver 1+ comes up a lot. So there are exceptions to the rules. Now, what the exceptions are, so for all three of these, so lead sulfate, let's now color code this somehow. Got an idea. Let's put this in. No, I've already used orange. Let's go for purple. No, blue. Blue. Yeah, light blue. Bit of blue. Bit of blue for your dad. There we go. Put it in blue. So lead sulfate, not soluble. Yeah, mercury sulfate, not soluble. Silver sulfate, not soluble. Do you see what I'm doing, guys? I'm matching the ion to the person in NAGSAC. Yeah. Also, it also ties in to the group 7s. Lead chloride, white solid. Lead iodide, yellow solid. Mercury 2 chloride. I have no idea what mercury 2 chloride is. Never seen it. Mercury 2 oxide is orange. I think. Red calx. Silver chloride. White. Silver bromide. Cream solid. This is the important bit, guys. And we need more examples here. E.g. silver chloride. Solid, insoluble. Yeah? Because it matches one of my exceptions. I've got PMS, silver, with the sulfates and the group 7s. So insoluble. Let's choose another one. Let's go for mercury sulfate. Perfect. So we've got Hg. By the way, mercury, it's really poisonous. It's like a hug, but without you. Is that the word? Hug with the mercury sulfate, solid, insoluble. Yeah. Can go for silver sulfate. Yeah, silver sulfate, solid, white, insoluble, solid. Yeah. Key things. So I know at this point people are going, oh, this is complicated. It's not. These are rare in the exam world. They do come up every year, and I'll show you. I can even tell you what the most recent one was, which was a disaster, by the way. My year 11s didn't catch it at all. The next solubility rule is Castro-Bear. Castro-Bear. See what I did there? Hug without you. Like, because it's HG. Of course, like, it's because it's Jack, well done. I have to say, if someone has to explain a science joke, I feel like I've lost it. Castro-Bear, calcium 2+, Ca+2, strontium. Now, what you guys, I'm hoping that you guys have all noticed, Sr2+, yeah, and barium. These are all group 2 metals, yeah. And these, the barium, strontium, carb, tie in to the sulfates. Their group 7s are soluble. Yeah, I'm glad you liked it, KB. So I flagged that now. Now there's one more rule we need to add to this. Now the problem is that there is another letter I need to add here, guys, to nugsag, which is I need to add on the carbonate rule as well. So carbonates, I will add this on as a separate rule, completely separate, but just to point out this one, so this is linked in nugsag. Yeah. Oh, I never need the top bit. They're all soluble. Right. Sulfates. This is what these tie to. Yeah. So these tie to these. And, by the way, I have in the past taught it as SCAG, but I don't like it. I didn't like it. Yeah. So this ties to the sulfates. So the example is barium sulfate, solid, insoluble, solid. Yeah. We can go calcium sulfate, an insoluble solid. Yeah. All of the group 2 sulfates. This also ties in to the carbonates. Yeah. So if you have, there is actually a different rule I tend to run for the carbonates. So the carbonates are, if you ever have a 2+ with a carbonate, you're insoluble. Yeah, so this actually translates to other things like the transition metals. So this is the final rule, carbonates. This is an extension rule, and it comes up at GCSE, unfortunately. Carbonates, if you have a 2+ cation, for example, e.g., what am I doing? E.g., yeah, if I have calcium 2+, barium 2+, iron 2+, copper 2+. If you have any of these next door to the CO3, CO3 2- ion, they're insoluble. Yeah, any 2+ carbonate is insoluble. So that's the rule. Any, I'll write it in blue, any 2+ carbonate is insoluble. So all group 2 carbonates, insoluble. Yeah, so calcium carbonate, insoluble, because that's calcium 2+ and CO3 2-. Yeah, so then we can go, so that's insoluble. We can also go iron 2 carbonate. Yeah, this is Fe 2+, and this is 2-. It's insoluble, green. Yeah, we can go copper carbonate. This is copper 2+. This is CO3 2-. It's a solid and it's green. It's actually turquoise. It's actually green-blue. I know. They allow green though. It's really annoying. So all of these are insoluble. Insoluble. And guys, we're done. Let's go back to my learning objectives. Solubility rules. Tick. Done. And yes, it's a pain because you've got to learn them. I'm sorry. I'm sorry, everybody. It's just the way it is. Right. Practical to find solubility. So the first thing is, let's put this into an exam question and look at some of these insolubles. So can you just underline that, please? And put practical. Practical to find solubility. Solubility. Here we go. What are the exceptions for ammonium? There are none. They're all soluble. Done. Nah. There are none, Julius. That's why I put it. That's why I didn't flag it. These are all soluble. All ammonium salts are soluble. There are no exceptions. Oh, hang on a minute. You're like, so why didn't you just do nag-sug? Oh, there will be exceptions. Let me see if I can find one. Oh, Julius, you've beaten me. Hang on a sec. Ammonium salt that's not soluble. There must be a reason why I put it there. Ammonium salt overview. Solubility of ammonium salts when amines are, yeah, whatever. Solubility. When why are they talking about amines? I want amines and amides. Go away. Side reactions. No, I want inorganic. Inorganic. I've been beaten. Good question. No, I don't want ammonium chloride. That doesn't help me. Liquid ammonia as a solvent. Liquid ammonia. Solubility of inorganic salts. Inorganic salts. That's not going to help me. Okay, Julius. If I don't know it, you don't need to know it. Sorry about that. It's going to be exceptions when it's joined in with other things. Don't worry about it. You don't need to know it. The answer is there are none. So if you want to change it to nag-sug, you can do. I'm so sorry. Yeah, I've done it in the exceptions area. Oh, no, that's going to really bug me. I'm so sorry. I'll fix it. I'll fix it. Ammonium. Oh, I think I found the answer. Solubility. I want something which is... Look how long there are. Loads of them. Loads. So the question is there any without a value? So they've got all the values for 20 degrees. So ammonium starts here. Ammonium acetate is quite low. Oh, ammonium azide, that's low. Ammonium chlorate, that's quite low. Oh, ammonium hexachloroplatinate. Do you see why I don't know them? Oh dear. They want massive numbers. Hydrogen tartrate, that's really low. How fascinating. Ammonium vanadate. Huh. I do know that salt. It's yellow. Huh. So there you go. Yeah. So you don't need them. Yusuf, hi. Thanks for coming along. I love the fact that you're saying good morning. It's like 2:30 in the afternoon here, Yusuf, but it's so good to have you with us. Thanks for coming. Anyway, let's get back to this. Yeah, so no exceptions for ammonium. Yeah. Right, practical defined solubility. Okay, so what we're going to do is we're going to take 100 grams of water. You probably wouldn't use 100 grams, but you don't see why not. It's an easy amount. 100 centimeters cubed, nice and easy. Got 100 centimeters cubed measuring cylinder, perfect. And what we're going to do is we're going to weigh out an amount of solid. Let's say 1 gram. Yeah, we're going to weigh out 1 gram of salt X. Yeah. Now what we're going to do is we're going to transfer that salt to the water and we're going to stir it. Yeah. Now, if it completely vanishes, we add more, add another gram and then stir it, wait for it to dissolve. If it completely disappears, add another gram. You keep going until it stops dissolving. You keep adding in 1 gram increments, 1 gram increments until no more dissolves, until no more will dissolve. Now what you do, let's say it took 3 grams dissolve. Yeah, no more will dissolve. So let's say we can have a little table here and it would have grams, yeah, and yes, no, dissolve, and it would be 1, 2, 3, 4, 5. So we go yes, 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 no. Right, so we now know that the solubility of X is between 3 and 4 grams. So now what can I do? I now have what looks like this. I now have 100 centimeters cubed and a small amount of X that just won't disappear. So what I'm going to do is I'm going to filter it. Yeah, I'm going to filter out X, pass X through a filter paper, get my clear solution, and the leftover, the undissolved X, left on filter paper, Can I just point out I've made a mistake in my method? You'll see it in a second. Now what we're going to do is we're going to take that and we're going to dry it. We're going to dry it in a drying oven. Yeah. Now what we have is our dry solid left behind. Now this is where I've made a mistake in my method. I needed to weigh the filter paper before I used it. So I need to make sure I record the filter paper before and the filter paper after. Filter paper and X solid. And what I can now do, let's say the filter paper weighed 0.5 grams and I had 0.73 grams at the end of it, I can tell you that X equals 0.23 grams. So my solubility of X is 3.77. I need a calculator. 2.3, because I added a gram, didn't I? So I need to do 1 minus 0.23, which gives me 0.77. That's going to be worth a mark. So that's its solubility per 100 grams of water at 25 degrees Celsius, as long as I've recorded the temperature. So that brings me to the end of my lesson with 2 minutes to spare. Thank goodness it was tight. Whew! We got through it, folks. Now, guys, what I'm going to do is I'm going to post you on the Google Classroom some solubility questions to have a go at, and I will go through them next lesson as part of our revision. I'm going to do a revision lesson next lesson on acids and base theory in preparation for your test. But that brings us to the end of acid-base theory, folks. We are done. How amazing is that? Stop share, switch my camera to the front. Oh, there we go. Guys, I hope you've had a nice afternoon and that all made sense. If you've got any questions, send me a message on Google Hangouts. Can I do a big shout out to KB, to Yusuf, to Mita, to Winkit? Thanks so much for coming along, guys. I really appreciate the support. Yeah, you guys are doing great. Guys, have a nice rest of your day. See you later, everybody.